In this video of the week, we're going to talk about properties of logarithms. Before we get into our first property below here, I want to mention a couple things. Logarithms always have a base, of course. And if that base happens to be 10, say the log base 10 of x, the mathematical powers that be have decided that we don't need to actually write the base on that. So if you ever see a logarithm without a base at all, it means it's base 10. You've also learned about this number e in this chapter. And if you happen to have a log base e, we have a different name for that. We call that a natural log, or log natural in this case of x. So if you ever see ln of x, what that means is it's a log with a base of e. Okay, let's talk about our first property of logarithms. Here it is right here. Some people call it the addition property for logarithms. I've also heard it called the product rule for logarithms. If you have two numbers inside of a logarithm that are multiplied by one another, you can split that logarithm into two pieces. So let me give you an example. If you have the log of any base, but in this case I'll just make up a base of 2, of 32, we're allowed to split that up into the log with the same base of, say, 4 plus the log base 2 of 8. The reason we're allowed to do this is because 32 can be written as 4 times 8. Now this property might make a lot of sense to you if you think about what these values actually are. Log base 2 of 4, that is the power on 2 that would give you 4. Most people would be able to tell you that that is a 2. Log base 2 of 8, that's the power on 2 that would give you 8. And that's 3. If we go to the left side of the equation, log base 2 of 32, what is the power on 2 that would give you 32? Well, if you count it out, 2, 4, 8, 16, 32, you get that the power on 2 that would give you 32 is actually 5. So you can see, at least in this example, why this property maybe makes a little bit of sense. Okay, the next property of logarithms, sometimes called the quotient rule, is that if you have two things divided inside of a logarithm, you can, again, split that logarithm up into two pieces, except this time, subtract. So if I just want to give you a real quick example, the log, in this case, there's no base, so it's base 10, of 1,000 over 10, you could split up, if you'd like, into the log of 1,000 minus the log of 10. And of course, you can see if you can make sense out of this whole relationship. Keep in mind that m and n don't have to be numbers, they can be expressions. So the log of, say, x over 12, I'm just making things up here, of course, can be written as the log of x minus the log of 12. And again, it doesn't matter what the base on any of these is, as long as in each equation the base is the same on the left and the right side. Okay, my favorite property of logarithms is this one right here. It's that if you have something to some power inside of a logarithm, you can actually take that power outside of the logarithm and put it in front. So as an example, if you have the log base 3 of x to the 5th, you can take that 5th power and you can move it outside of the logarithm. Keep in mind that this 5th power is only on the x. And we're allowed to take that 5, move it outside the logarithm, and put it right there. I want to try to make a little bit of sense out of this rule just really quickly. If we consider x to the 5th to be x times x times x times x times x, and we consider the very first rule that we learned, that if you have things multiplied inside of a logarithm, you can split them up into the sum of logarithms, then what that means is we could take this example right here, this log base 3 of x times x times x times x times x, and we could split that up into 5 pieces. If we split that up into 5 pieces, what do we have? Well, we have 5 of those. We have 5 log base 3 of x. Okay, so that's a really quick explanation. Let's put this into practice a little bit. Let's expand this logarithm into several pieces. I'm going to do it in more than one step. I'm going to use the second rule above, what we sometimes call the quotient rule for logarithms. I'm going to recognize that we have a quotient inside this logarithm, and whenever we have that, we can split it up into the difference of two logarithms. Now, I tend to be a little bit loose with my parentheses. We could have parentheses around all of these if we wanted. For clarity purposes, maybe that's a good idea. Okay, let's continue to expand this logarithm. What I'm recognizing now is that we have a product right here of two functions inside of a logarithm. What the first rule says is that we can split that up into two pieces and add them. And I'm just going to copy down this last logarithm that we have at the end here. Okay, now if we want to fully expand this logarithm, what we can do now is we can use the third property of logarithms, which says if you have a power on something inside of a logarithm, you can bring that outside. Okay, we've used all three properties in this example here. Now keep in mind that we can also reverse this process. We could also be asked to write a bunch of logarithms as a single logarithm. In this example, we have a natural log. Remember, that's a log base e. Still follows all the same rules as other logarithms. We would like to condense this into one logarithm. So we can actually reverse this process. We can start with our third rule just in reverse. We can take a number outside of a logarithm and put it on the power of the thing inside the logarithm. There you go. I took all of the coefficients out in front of the logarithm and I moved them up to the powers inside the logarithm. Now I'm going to recognize that there's a subtraction of two logarithms right here, and I'm going to combine these two together using that quotient rule again. Again, I could have parentheses around all of these terms right here, and that would be perfectly fine. But notice what changed here. We combined these two logarithms into one logarithm by sort of reversing that quotient rule, that second rule from above. Now what do we have? Well, we have two logarithms that are added together. We can use our first rule in reverse to combine those two. We do that by multiplying what's inside of the two logarithms. There we go. And then just notation-wise, if we're multiplying this stuff out, this y to the 6 is just really multiplying the numerator. So to clean it up a bit, we can write it like this. Okay, just a quick video this week. I hope that helps you out. Let me know if you have any questions.